I cooked up this very crazy piecewise function to illustrate a lot of the limit ideas that we've been covering. And so it's, I can't imagine anything realistic fitting anything like this, but anyway, it'll serve our purpose for talking about limits. So let's start off by looking at what happens as x goes to minus infinity. So this one has a horizontal asymptote, and it's approaching the horizontal line, and which is 2, y equals to 2. So the limit would be, as x approaches minus infinity, would be positive 2. All right, so as an asymptote, it approaches but never quite touches the line as x goes to one of the infinities. Now it's possible for a function to have 2 separate horizontal asymptotes. A little unusual, very unusual. Just the average everyday function either has no asymptotes at all, horizontal asymptotes, or it might have 1. But it can have 2. It cannot have 3, though. You might want to think about why couldn't a function have 3 or more horizontal asymptotes? Well, it's very simple. There's only 2 infinities, negative infinity and positive infinity. So, all right, now, if we let x approach positive infinity, now we're down here, and it's leveling off at y equals to negative 1. So I'll have to change this to negative 1 as its limit. All right, so in this case, both infinite limits existed. And many functions, when x goes to infinity, then the function itself goes to infinity or minus infinity. So this is just an example. All right, now then, what happens as x approaches minus 3 from the left side? So when x approaches negative 3, you probably got the answer in your head. It approaches this hole in the graph, which is at 1. So it'd be 1. This is from the left side. So make sure you have a negative 3 to the minus 1 equals 1. It's actually not raised to the minus 1. It's just, it means negative 3 from the left. So it approaches 1. But if you approach from the right side, it approaches minus 2. So if I change this to a plus, then my answer becomes negative 2. And what would happen if you just wrote, what's the limit as x approaches negative 3? Well, it has 2 different answers, so it would not exist. So if I change this, if I don't specify left or right side, if it's a 2-sided limit, then that would be, does not exist. Okay. Now then, moving on. Oh, another thing we could say, well, what's the value of the function at negative 3? And that would be this point, because it's defined at the dot that's colored in. Up here we have a hole, so it doesn't equal there, but it does equal to this number, which is negative 2. So the function is also minus 2. Okay, well, let's see, what happens over here as x approaches negative 2 from the left side. So minus 2 from the left side. Whoops. Okay, I'll get that right. Minus 2 from the left side is going to be negative 1, right? Because it comes up to here, it just approaches this hole in the graph. So that's minus 1. As x approaches 2 from the right side, it comes down and gets close to positive 1. So if I change this to 2 from the right side, then it becomes positive 1. So my limit is positive 1. Now the limit as x approaches minus 2, as you can see, they're both different. There's that gap there, is that discontinuity. And so as x approaches minus 2, in general, we say the limit does not exist. Does not exist. However, the value of the function turns out to be something entirely different, because I have this straight dot up here. So f of negative 2 is going to be 3. Positive 3. There we go. Okay, well, more of this stuff. How about if I, to save a little time with all that writing, let me just verbalize this out. You take good notes, okay? So let's talk through the rest of this, if you don't mind. Well, it wouldn't matter if you minded anyway, would it? Okay, it's a video. All right, so as x approaches -1 from the left side, x approaches -1 from the left side, what's happening? It's going to positive infinity. So that limits positive infinity. If you approach -1 from the right side, it's still positive infinity. So the two-sided limit does exist. The limit as x approaches -1 is the same on either side, positive infinity. So that took care of that vertical asymptote. Let's see. This is, the limit at 0 is going to be 1. The function is equal to 1. Function at 0 is 1. Both sides are equal. So nothing is going on here. And actually that's a working definition of continuity at a point. When a function is continuous at a point, the value of the function is equal to the two-sided limit. In other words, there's no holes or gaps. It's that simple. And okay, by the way, I forgot to mention that f of -1 does not exist. So all the limits both go to, from either side, go to positive infinity. The value of the function does not exist because you get division by 0 there. All right, over here, this is removable discontinuity. So the limit from the left side as x approaches 1 is going to be the x-axis, which is 0. So limit from the left is 0. Limit from the right side is equal to 0. So the two-sided limit does exist. Limit as x approaches 1, two-sided limit is equal to y equals 0. However, the function is not defined at 1. Okay, so f at 1 does not exist. So this is a removable discontinuity. And over here, of course, the limit as x approaches 2 from the left side is going to be -2. From the right side, that limit is going to be +1. But the value of the function does not exist. We don't have a value, a point for x equal to. So it's undefined at 2. Although these, both the left limit exists, the right limit exists, and because they're unequal, the limit does not exist. So it's different from this kind of removable discontinuity. I can't remove the discontinuity and have a continuous function. This is still going to have a gap. All right, limit as x approaches 3 from the left is -infinity. As x approaches 3 from the right side is positive infinity. So the limit does not exist as a two-sided limit. Limit as x approaches 3. Two-sided limit does not exist because those are different infinities. And of course the value of the function does not exist there. Over here, starting to get repetitive. Well, we got one more. Okay, limit as x approaches 4 from the left-hand side would be -3. Limit as x approaches 4 from the right side is +1. The limit as x approaches 4, two-sided limit, does not exist. However, the value of the function is the colored in dot, -3. So f at 4 is -3. All right. And we already talked about the horizontal asymptote. So that's a crazy function. It kind of recaps a lot of types of, actually about all the limits I can think of that we've talked about as far as behavior on a graph. And so anyway, that's the recap.